Well, let's get started. Good morning. Welcome to Sunday School. Today is our last week of the Answers Bible Curriculum series before we take our summer break. We know that we've been going through the Answers Bible Curriculum. We're just finishing up our third quarter, but we're going to take a break for the summer. Next week, and for the rest of the summer, we're going to be doing a mini-series, a new series on biblical archaeology. Biblical Archaeology 101. You've hopefully seen the inserts in the bulletin. That is, we'll be taking a survey through the most important archaeological discoveries related to the Bible. And the events of Scripture really did happen, and the evidence left behind not only directly confirms much of what the Bible declares, it also helps clarify and give context to the information that the Bible does present so that we can understand it a little bit better. Please note that our summer Sunday school class will be a combined Sunday school class. That is, children of toddler or kindergarten, pre-kindergarten age range will still meet downstairs for Sunday school class, but all other age levels will be in here. They'll be joining us in here to learn about biblical archaeology. But before we get to that, one more lesson. Today we're pausing our walk with Abraham and the patriarchs to address an issue that has been lingering in the background since the flood. That issue is the Ice Age. Does the Bible talk about the Ice Age or an Ice Age? No, it doesn't. However, the Bible does clearly describe a worldwide flood. And as we're going to see today, the Ice Age and the flood are very intimately connected. So the format of today's class is going to be a little different than usual. We're going to be listening to a lecture from Michael Oard, a retired meteorologist who's been working with Answers in Genesis since 2001. In this video lecture, Oard articulates why creationist scientists do believe in an ice age and how the ice age ties into the Genesis flood. The lecture is about 25 minutes, but we're going to break the lecture into 3 sections, and after watching each section, we're going to recap the information. The information from Oard comes kind of fast, and I want to make sure that we understand the arguments that he is presenting. To help keep things as clear as possible, I've also created a note-taking outline for you to use as we watch the video and as we discuss the video. So please make use of it, fill in the blanks, answer the questions, help your understanding as you listen. Each time we pause, we'll make sure to go over the notes so that you have the correct information. Understand that the goal of today's class is to not answer every scientific question related to the Ice Age. Rather, my goal and Answers in Genesis goal is to give us a basic understanding of the Ice Age and how the Ice Age ties into the Bible. One final note, remember that what we're talking about today is theory. It comes from fallible interpretations of data. Like when we spoke about the science of the flood earlier this quarter, we cannot treat these theories like Scripture. These theories are not inerrant. Models of the Ice Age or of the flood have been revised since their inception, and they will continue to be revised or replaced as we get more information to help the models better accord with the Bible and the scientific evidence that's available. That being said, these models are useful for investigating various scientific questions that arise today. Questions like, why are there ancient rock paintings of fish in the Sahara Desert? In the Sahara Desert, why are there paintings of fish? How did man and animals get to North America after the flood and Babel? And why did animals like the woolly mammoth and the saber-toothed tiger? By understanding the model we're going to talk about today, help us go about answering those questions. Moreover, even though many of us are not scientists, we nonetheless must navigate continual scientific claims from the media and from our education systems. They say, here's what science has found, this is what science has found. We want to be able to skillfully assess such claims and determine whether they are empty or reasonable. So, today's lesson on the Ice Age should still prove useful to you. Here's our outline for today's class. We're going to review some basic bits of information regarding the flood that we discussed in a previous class. Then we'll actually listen to and review the arguments of Michael Oard via his video lecture. And then finally, we'll briefly compare the arguments that he presents with current secular thought regarding the Ice Age. Let's pray before we go on. Lord God, you are the great, faithful God. You keep covenant. Lord, we are so glad for your faithfulness to preserve the world. Ever since the flood, you promised that you would preserve it until the end. And God, that you've also promised, because you have chosen to enter into covenant with your elect, Lord, you've promised to always provide. You've promised to be God to us and to take care of us in your perfect and wise way. Lord, as we discuss these topics today, I pray that it would be edifying to the people. I pray that you would give us understanding. I pray, Lord, that it would also provoke wonder at your greatness, all that you accomplish in the world. In Jesus' name, amen. All right, let's start by reviewing some information about the flood. You'll remember that the flood record in Genesis, presented to us as straightforward history in chapters 6 to 9, identifies two sources for the flood waters. What were those two sources? Yeah, Steve.
The sky, the heavens above, and the fountains of the deep.
That's right, the fountains of the great deep and the floodgates of the sky. Those are the two sources of water identified for us in the text. All the waters that flooded the earth were a result of those two sources: fountains from deep underneath the oceans and water from above. Now, we took time during one of our classes to explore a specific creationist model of the flood. What was the name of that model? Very good. Catastrophic plate tectonics. According to this model, what basic but momentous change physically caused the flood? Yeah, Danielle.
The shift in the plate tectonics, which caused, I guess, heat and steam to break through the ocean, which caused the water to rise.
We'll talk about the mechanism specifically in just a second. We'll review those. But yes, it's all about the tectonic plates breaking apart and moving apart. Catastrophic plate tectonics. It's just about the movement of the plates of the Earth's crust. I'll remind you of those three specific mechanisms resulting from the movement of the plates that would cause the flood. First, fissures in the oceanic crust, gaps in the oceanic crust, brought in lots of hot material from the mantle, that is the second layer underneath the crust, causing large amounts of steam to rise into the air from all over the oceans because all these gaps were appearing. These large amounts of steam caused rain clouds to form rapidly and continually, and massive precipitation fell on the land. So we have steam rising, causing rain. Then the movement of the plates also caused the oceanic crust to be replaced. In the process of subduction, new hot material from the mantle replaced the surface of the ocean floor. This new seafloor, or replaced the ocean floor. This new seafloor was hotter and less dense, causing it to float higher on the Earth's mantle, and consequently the sea level rose. So we've got steam causing rain. We've got a less dense oceanic crust, which rises or causes the sea levels to rise. And then finally, the tectonic movement and the volcanic activity caused by the movement of the plates caused massive tidal waves to continually strike the continents. So these three forces brought massive amounts of water on land. What then caused the floodwaters to recede, if these indeed caused the floodwaters to rise? Why did it stop? Yeah, Steve.
Based on your description, I would assume that once the ocean bed cooled even more, it became more dense and lowered.
Exactly. Eventually the gaps, those fissures in the ocean, closed, so you had no more hot material from the mantle, causing steam to rise, so the rain clouds disappeared. And then that new ocean floor was finally finished being remade, and it cooled. Its heat dissipated into the ocean, and so it cooled and sunk lower on the mantle. Therefore, the sea level dropped. And because the plates eventually stopped moving or began to move only slightly, you no longer had the intense tidal waves that accompanied the earthquakes and the volcanic activity, though some volcanic activity, or a good deal of volcanic activity, probably continued. Anyways, so these things settled down and the flood waters receded. Of course, God was in control of all these forces, but this is one explanation for what physically caused the flood. Now remember, this is a theory. It does accord well with various pieces of geological evidence, as we have discussed, but it's just a theory. One other thing to mention to you before we talk about the Ice Age, there is another flood theory that suggests that there were, or are, massive amounts of hot water trapped underneath the mantle, and those broke through oceanic crust during the flood. So literal fountains gushing water, not just causing water to turn into steam, but gushing water into the oceans and basically increasing the levels of the sea that way. This would be hot water from underneath the mantle. I've talked about the other theory because I think that accords better with the evidence, but I mentioned this alternative to you because both catastrophic plate tectonics and the idea of hot water coming through the mantle, they both would produce conditions conducive to an ice age, as we'll see in just a few moments. Before we start listening to the lecture, though, we should actually define what is an ice age. What is an ice age? Well, it sounds really dramatic, right? Perhaps the term brings to mind a completely frozen planet. But it actually doesn't need to be that drastic. An ice age, and you can write this down on your notes, an ice age is simply a period of time with extensive glaciation. That is, substantially more land covered by ice. I'll say it again. An ice age is a period of time with substantially more land covered by ice. Doesn't have to be the whole Earth, doesn't even have to be half the Earth. It just has to be substantially more than is normal. Today, there are a few places you can go to see land permanently covered by ice. What's one of those places? Antarctica, right? As a place that has permanent ice coverage. It has permanent glaciers. Also in the Antarctic, we find places like that. And also at high altitudes, you have places that are permanently covered by ice. Currently, 12%, scientists say 12% of Earth's landmass is permanently covered in ice. An ice age, then, would mean a substantial increase in that percentage, substantially more than 12%. That would be an ice age. Okay, was there an ice age? How bad was the ice age? Can we explain how it happened? What evidence is there to support such an explanation? That's what Oard is going to present to us. So let's actually cue up the first section of the movie. It'll be about 8 minutes. We'll watch it, and then we'll recap the information.
Was there an ice age? Well, when you examine the superficial sediments, the sediments that are on the surface of the Earth, in presently glaciated areas, you see a number of features. Now, this is the beautiful Athabasca Glacier in the Canadian Rockies that is. Was there an ice age? Well, when you examine the superficial sediments, the sediments that are on the surface of the Earth, in presently glaciated areas, you see a number of features. Now, this is the beautiful Athabasca Glacier in the Canadian Rockies that has been receding. This sign right there, that's where it was in 1890, and yet it has been receding. And when it leaves behind, you can examine what an ice does. It leaves behind rocks of all sizes within usually sand and silt, kind of in a finer grain matrix. It leaves behind end moraines and lateral moraines. End moraines and lateral moraines are formed when the glacier pushes out material ahead of it. And as it's along the side, it's called a lateral moraine. When it's in the front, it's called a terminal or end moraine. Speaking of this, I can't help but make a comment on global warming. Yes, all glaciers of the world have been receding, or mostly all. And yes, it is true there has been global warming, and I believe it is true that man has been a cause of it, but I believe that nature is part of it too, because between 1350 and 1850, we had the Little Ice Age, where all the glaciers in the world advanced. Now we're in the opposite fluctuation where they're receding. So I think this is partly due to the effects of the sunshine and less volcanic ash in the stratosphere, of why we're getting some of the global warming. There's a beautiful in moraine, very sharp looking, made not too long ago, probably made about 1890. Another feature you observe around glaciated areas is scratched bedrock. As the glacier moves over bedrock, it has rocks in the bottom of it, and those rocks in the bottom scratch the bedrock. So it's typical to see striated bedrock, or pavement as they call this. Also, some of the rocks themselves get scratched, and a lot of times they get scratched in different directions. Here's one set going that way, and there's another set going this way, like this. And it's probably because the rock turned a little bit in the ice. The ice is more plastic and malleable, so that's probably why you have striations in different directions on rocks. So those are some of the features we see in currently glaciated areas. So let's extend those to features where it's claimed to have been glaciated. Here's one area where I used to live, west of Great Falls, Montana, near Augusta, Montana. This is the Rocky Mountain front. The Rocky Mountains were glaciated during the Ice Age, and the ice came about 10 miles out onto the high plain and formed this end moraine, just typically is what you see at the Athabasca Glacier. I'm taking a picture of this from this part of the end moraine right here. It was breached right in here. Probably when the glacier melted, it breached through the end moraine right here. So that's why there's a gap there. When you look at the material in the end moraine, it's very similar to glaciers you see today. It's rocks of all sizes in a finer grain matrix surrounding the rocks. Typically, they call that glacial till. Also, when you go up into the Rocky Mountains, you see scratched bedrock going east. In fact, there's an 800-foot cliff right along here. The glacier came up out of this valley, scratched the bedrock, and went down over an 800-foot cliff. Also, you find in the moraine that I showed you previously, you find rocks that are scratched in several different directions. Typical what you see in glaciated areas. And this is in an area that gets up in the 80s for high temperatures in the summertime. Also, as you tour around the west, you see that out of some of the mountain valleys of the western U.S., you see moraines, just like you see at Athabasca Glacier. This is probably one of the best moraines that I've ever seen before. This is the horseshoe-shaped lateral end moraines around beautiful Wallowa Lake in northeast Oregon. It moved out onto the Enterprise Plain in northeast Oregon, about 4,000 feet altitude, where it gets probably a high temperature of 90 as the average in July. There's the lateral moraine, end moraine, and lateral moraine. They're fairly sharp looking, indicating that the Ice Age ended not that long ago. Furthermore, a feature like this could not form during the flood. This feature has to form by other mechanisms, and it's on top of flood sediments, so the Ice Age occurred after the flood. And here's another picture of that lateral moraine. You can see the trees for scale. This lateral moraine is 600 feet tall. And here's what you see within the lateral moraine: glacial till, rocks of all sizes in a finer grain matrix. And you see these around the Sierra Mountains and other Wind River Mountains of the western United States. Also, you see these erratic boulders here and there. Most of them I see are kind of sub-rounded or rounded. I think that a lot of erratics were transported by water. This one is very angular. This is the famous Okotoks erratic, southwest of Calgary, Alberta. This forms a line of erratics from Jasper, Alberta, down into northern Montana, just kind of a line, and very angular, which means they didn't roll down there. Probably they were deposited by icebergs as ice was melting. Here's another famous erratic called the Bellevue erratic. Now this erratic is, erratic boulder is a boulder rock that in the local area. It's been transported somehow. That's what they mean by an erratic boulder, or exotic boulder is another name. This one is found southwest of Portland, Oregon in the Willamette Valley. It's composed of argillite, which is a slightly metamorphosed shale, and the nearest outcrop of that is in northern Idaho. And it's well south of the ice, where the boundary of the ice, by the way. How did it get down there? And it's very angular. The only way you can think about it is on an iceberg. And how would an iceberg take it down there? Well, when Glacial Lake Missoula broke, it spread through eastern Washington, through the Columbia Gorge, and spread over Portland, Oregon, 400 feet deep and up into the Willamette Valley. So if there was a glacial Lake Missoula and a Lake Missoula flood, there had to be a thick ice dam in northern Idaho to block up the water in the Clark Fork Valley, indicating again that the ice age was a real event. Ice covered practically all of Canada. Just a little bit in the Yukon Territory was unglaciated. It came down in the northern United States to around, they claim, northern Missouri, and I'm not quite sure that. That's a subject of research, but it got pretty far south of the Great Lakes, and it covered some of the mountain areas as ice caps. But interesting enough, in Alaska, the Brooks Range and Alaska Range, they were glaciated, but the lowlands of Alaska were not glaciated. And that's where you find all those woolly mammoths, bisons, and horses, and lots of animals in Ice Age permafrost in those areas. When you go to Europe and Asia, this is the general feature where the ice was. It covered much of England and northern Germany and Poland, and clear out in the now there's a little question on the boundary right in here, and some people think that the ice covered the Barents Sea north of Norway there. So there's still some controversy over the exact distribution of the ice. But when you add it all up, ice covered 30% of the continental areas. The closest ice to this area would have been up in Pennsylvania. Can we explain it? Well, I believe we can. First of all,
All right, now let's recap. So to determine whether there was an ice age, let's look at the areas where we know there is ice now and see if there are any distinctive features in that area, distinctive geological, topographical features, and then see if those features are repeated elsewhere. That would show us whether there was ice. There were ice sheets, there were glaciers in that area before. And he describes a couple of those features that are distinctive of ice-covered areas. Existing glaciers, they impact the rocks and soil in two ways, and one is with moraines. And he mentioned two types of moraines. What were the two types? Terminal or end moraines, and the other is lateral. So those are the two blanks there, lateral and end moraines. But what is a moraine? He defines it a little bit after he starts talking about it. What's a moraine? Or say it again, Roy. Well, it's not actually the shape of the glacier's path, but the rock and soil that is pushing to the sides, they have a distinctive makeup. And that's what a moraine is. It's that rocks that's pushed to the side. And how are they made up? Or what are they made up of with?
Combinations of small rocks to large rocks that are kind of all mixed together. There's no real uniformity in them.
Exactly. It's a mixture of rocks of all sizes in a fine grained matrix, as he says, or something like sand. So I'll give you the straight definition here once I find it again. A moraine is a collection of various sized rocks in a finer grained matrix. So it's like a big pile or a big wall of various sized rocks in a finer grained matrix. And he showed you a number of pictures of those things. Basically a collection of mixed rocky debris all shoved together because something really powerful pushed it that way. Moraines have another name. They're also called glacial what? Glacial till. Glacial till. So you can see these in ice-covered areas today. They're formed when glaciers, as I said, giant ice sheets, that's what a glacier is, it moves or expands. And this powerful moving ice pushes with great pressure on the rocks and soil in its path, shoving them to the side, which is a lateral moraine, or shoving them in front, which is an end moraine. Moraines are very distinctive. If you find moraines, you know that there is a glacier there. Or there's a glacier nearby, or there once was a glacier there. And what's the other main sign of ice coverage that he talked about that you can see on an area's rocks? We'll talk about the erratic boulders in just a second because that's another sign, but before we get there, that's right, scratches. Scratches on the bedrock, striated bedrock. As a glacier expands, it sometimes picks up rocks or carries rocks, and the rock and ice lays deep scratches in the rocks that it passes by or that it carries, because that rock is scratching against other rock, or the ice is scratching against the rock, and it leaves scratch marks in the rock. Rocks that are not carried are pressed against the rocks by the ice sheet, but some rocks are even carried. As these carried rocks turn, they can even get scratches going in different directions. So, scratched bedrock is a telltale sign of ice coverage, an expanding glacier. So we find moraines and we find scratched boulders all over the northern hemisphere, along with, as you mentioned, Sarah, erratic boulders. What are erratic boulders? Yeah, George. Exactly. They're rocks that have been transported into an area, and we believe they're transported into an area because they don't match any of the other rocks nearby. They're exotic boulders. They're alien boulders. They've been transported somehow because they don't match the other rocks. He mentions that many erratic boulders are rounded, meaning that they were probably carried by water and part of their sides were smoothed off, but many erratic boulders are very angular in shape, which means that a river or liquid water didn't carry them, something else did, likely glaciers. Glaciers and icebergs, I guess moving glaciers, they can actually carry rocks in front of them or on them and push them into an area in which they didn't belong. So we find erratic boulders along with these other two signs in various places in the northern hemisphere. So because these land features show up in a lot of other places than where there are glaciers now, what is the conclusion? There must have been extensive ice coverage at one time that is not there now. In other words, an ice age, because that's exactly what an ice age is, right? Substantially greater ice coverage on land. There must have been ice sheets in various places in the northern hemisphere at one time. Conclusion. There must have been an ice age. Now, both uniformitarian, that is secular scientists who believe that processes today are exactly the processes that have always been acting on the Earth, uniformitarian scientists and creationist scientists agree that our Earth previously experienced an ice age. That's not really up for debate. They all agree on that. How far did the ice sheets extend in the northern hemisphere? What did it cover? It did come down to Pennsylvania about midway through the US, covered almost all of our northern neighbor, Canada. And what about Eurasia? What was covered? Parts of northwest Siberia, good part of Siberia. What else? Scandinavia, all of Scandinavia covered, most of England also covered. There was also ice coverage in the southern hemisphere. He doesn't really talk about it, but places like Chile, Argentina, most of New Zealand, and Southeast Australia were likely covered by ice. In all, about, as he said, 30% of the continents were covered by ice. That's a substantial increase of the ice that we have today. Questions so far? Yes, Steve.
So was that since creation or sometime after the flood?
That's something that he briefly mentioned something about, but that's a great question. Can we say that this happened before the flood or after the flood? Can we really make a distinction? And he said that we can say that these things appear after, or the ice age happened after the flood because the moraines and the erratic boulders and the scratched bedrock or maybe not the bedrock, but those other geological features, they appear above something. What do they appear above? That's right, flood sediments. The types of sediments that must have occurred during the flood or that are associated with the flood, these features appear above those, which means they must have come afterwards. That's actually a blank I have in the next section under Can We Explain the Ice Age? So the reason we think the Ice Age happened after the flood is because it appears above the flood evidence. It appears above flood sediments. Other questions? Dwayne, question? Okay. Yeah. Flood sediment. So that's a great question. Sediment is just soil deposits. It's a term for geological deposits. So it can, to my understanding, it can contain rocks, but basically types of soil. And there are certain types of soil that appear in certain rock layers, and there are some that would be created by the flood, and some that couldn't have been created by the flood. So yeah, flood sediments are, I'm not exactly sure how to describe it physically, but it's a distinctive kind of soil. Other question? Yeah.
And we can observe that in like modern day floods, like them leaving this type of sediment mixture?
That's a good question. Probably, I don't know that specifically, but we could see water carry sediment, and it carries a certain kind of sediment. So when you have a flood in an area, it does leave behind a certain kind of sediment, a certain kind of soil. When we think about the Nile River and how it made things really fertile, it's partly because of how it carried sediment. And so yeah, we'd be talking about that kind of sediment. This flood sediments actually appear all over the world. And so that's one of the reasons why we say that geological evidence accords well with a global flood, because you have these flood sediments all over the place. Yes?
I think also the assumption is that since we believe in a global flood, that whatever rock, whatever moraines there are, since they are on the top, they must be on top of what was before.
Right.
So that's the assumption.
Right. So because of the global flood, just to repeat your comment, whatever appears on top must have come after what was before, and what was before was the flood. Good questions. Other questions? Roy.
Just a comment. I think maybe it needs to be explained a little bit better where the ice came from, and that's not just the things froze. And we're talking about snow that took place over a period of many years, and that came, so deep. We're talking about, let's say, the northern United States that might have been hundreds of feet deep, but thousands of feet deep at the poles.
We'll talk a little bit more about that in just a second, but you're right, Roy. We're not just talking about things freezing due to water vapor in the air, but we're going to get some storms, some powerful precipitation. That's the next section, actually, of this lecture. He's going to explain, can we explain the Ice Age? Can we explain this ice buildup? So let's actually go over to that now. Andrew, if you could cue up the video again, let's hear another about 4 or 5 minute clip explaining how did the Ice Age come about.
The closest ice to this area would have been up in Pennsylvania. Can we explain it? Well, I believe we can. First of all, we can tell from clues that it's post-flood. It's on the surface of flood sediments, and we definitely don't have it today in the present climate. The ice sheets in Canada are gone. So it must have happened in a transitional climate from the flood to the present climate. Well, that means the flood could have caused the Ice Age. Well, indeed, I believe that is the case. So let's see how the Genesis flood fulfills the requirements for an Ice Age. It was a giant volcanic tectonic event. Tectonic is crustal earth movements. But at the end of the flood, you have a huge shroud of volcanic dust and aerosols. Aerosols are fine particles about a micron in diameter. They would be floating on the stratosphere. What they do, what we know from modern volcanic eruptions, they cause cooler temperatures, especially in summer and over the large land masses. So after the flood, you'd have so much volcanic ash and aerosols that you'd cause a pretty good cooling right off the bat. Also, the fountains of the great deep and volcanism cause a warm ocean. There's lots of ways to cause a warm ocean in any flood model, but the fountains of the great deep imply that there was water trapped in the crust, and it came up, and at the end of the flood, that warm water coming from the crust would have been added to the current oceans, resulting in a warm ocean from top to bottom and pole to pole. You could probably swim in the Arctic Ocean right after the flood, it was so warm. There'd be no sea ice. Anyway, the significance of the warm water is that the warmer the water, the more the evaporation. In fact, at 86 degrees Fahrenheit, you would have 7 times the amount of evaporation of water than at 0 degrees centigrade or 32 degrees Fahrenheit. Huge amount of evaporation with warmer water. Also, the mechanism is going to persist, but it's going to wane with time as the volcanic ash settles out and the earth settles down to equilibrium and the oceans cool. Particularly the oceans cooling is the key for the waning of the ice age. Here's kind of a schematic of how this would work. The volcanic dust and aerosols would reflect some of the sunlight back to space, cooling the surface of the earth, mainly the land masses at mid and high latitudes. Now, volcanic ash and aerosols filter out of the atmosphere, sink out of the atmosphere in about 1 to 3 years. So you have to keep replenishing the stratosphere after the flood. And indeed, there's a tremendous amount of Ice Age volcanism in Ice Age sediments, indicating we had tremendous volcanism for quite a while after the flood. Now, they know that, uniformitarians notice that, and they know volcanism causes cooling, but you know, when they stretch out the Ice Age into a 2 million year period, it's nothing. But when we telescope it into a short time scale, it becomes very, very significant. Now, with basic meteorology, you can guesstimate, that's meteorological jargon, the storm tracks during the Ice Age. Storm tracks would be in areas where you have strong horizontal temperature differences. And where would they be? They would generally be between the cold, cool land and the warm ocean. So you'd have a storm track parallel with the east coast. Also, another storm track would be cold ice sheet and a little bit warmer land here. So you'd have a storm track just south of the ice sheet. And storms would generally follow these. Now, these are general storm tracks. In meteorology, chaos usually rules, so these are just general. And most of the time, precipitation in wintertime storms falls on the north side of the storm. So it'd fall right in there where the ice was building up. In this schematic, this is where the ice is still building up. Also, you can figure out where the main evaporation areas are. Generally, with west to east flow, you'd have fairly drier, cooler air from the continent going out over the warmer ocean. That produces strong evaporation on the east coasts of continents. And of course, in Arctic Ocean, close to the land, you'd have strong evaporation. Those are close to the areas at the mid and high latitudes where you want it to evaporate. It's close to where the building ice sheets developed in Canada and the northern United States, and of course, Scandinavia.
All right, we'll pause right there.
Now I'm going to go on to support for the model.
Let's recap this section of the lecture. We already talked about when the Ice Age probably happened after the flood because of where it appears in the sediment layers. But meteorologically, the Ice Age is difficult because you need 2 seemingly contradictory preconditions to create an Ice Age. I left 2 blanks in the sheet. He doesn't identify these things specifically, but it's helpful for us to think about them. To have an Ice Age, you first of all need cooler temperatures. You need cooler temperatures. Why is that important? To cause snow and snow buildup, because even if you get snow, if there are warmer temperatures, especially in summer, what's going to happen to all the snow? It's going to melt. All the snow and ice is going to melt. So you need cooler temperatures, especially in summer, so that the snow can fall and so that it won't melt as easily. But to get snow and to get lots of precipitation, what do you need? You need evaporation, and evaporation happens more when the temperatures are what? Warm. So these things don't go well together. To get a large amount of precipitation, to produce the ice on land, you need warm temperatures. But to get the ice to actually form and to get it to stay, you need cooler temperatures. How's that going to work? How's that going to happen? This is a seemingly impossible problem for uniformitarian scientists. They see evidence for the ice age, but they can't really describe the mechanism because to get both evaporation, lots of evaporation, and cooler temperatures at the same time is seemingly impossible. One prevents the other normally. But what does give us these two preconditions? A warmer ocean caused by volcanic eruptions and the tectonic event known as the flood. The flood. The flood fulfills these two preconditions. As he says, the flood was likely a massive tectonic and volcanic event, as we've discussed. The flood was likely a massive tectonic and volcanic event. You've got hot mantle material spilling into the oceans. You've got volcanic activity erupting everywhere because the tectonic plates are crashing into each other. And this means that volcanic activity is causing volcanic particles to go into the air. Aerosols are finding their way into the stratosphere. The stratosphere is the second layer of our atmosphere. We dwell in the troposphere. Stratosphere is right above that. And these particles in the air, they block and reflect sunlight. Without many of the sun's rays reaching the ground, what does that cause on land? Cooler temperatures, especially in summer. Cooler summers. What are aerosols? Very, very, very tiny particles. Tiny particles that float in the atmosphere. Yes, Ron?
So, when they showed the picture of the ice, it was only like in the North Americas, right? So, like the tectonic plate and volcanic action during the flood happened all over the world, right?
Yes.
But there's only ice over there, so that's where it's cooler.
I think that is, yes, I think that's the explanation. Your question is, why was ice only building up in certain places at these certain sections of the northern hemisphere and certain sections of the southern hemisphere? I think it has to do with how much sunlight reaches those areas. They're cooler parts of the world. There might also be something about where aerosols gather. He doesn't talk about that specifically, but maybe that's also part of the explanation. So you have these aerosols, these extremely tiny particles, getting into the stratosphere. Yes, Danielle?
What was the answer to the question that said volcanic dust aerosols would have caused what on land?
Cooler summers. Generally cooler temperatures, but it also, as we'll talk about a little bit later, the Ice Age also had mild winters in various places. So don't just think that like everything gets colder. Some places, only the summers got colder, or they were not that affected by the Ice Age. So we get cooler summers on land due to the aerosols. And we know that this is what volcanic eruptions do because we see the same thing happening with modern volcanic eruptions. So we have that happening, which is going to cause the cooler temperatures, but the fountains of the Great Deep, the volcanism of the flood, it created a warm ocean, leading to high amounts of evaporation, which is that other necessary precondition of the flood. So this gives us a reasonable explanation for how the Ice Age originated. The flood gives you the two preconditions, and these mechanisms are long-lasting, but not permanent, which is important. They eventually will fix themselves. One problem uniformitarian scientists run into when they're trying to explain the Ice Age is that sometimes they can get an Ice Age to start, but they can't get it to stop. You get a frozen Earth. That's a problem. And they have to infer, like, suddenly there's a spike in carbon dioxide and the whole world melts. Well, what caused that? Hard to explain. So the flood provides mechanisms that produce an Ice Age, but also wane with time. Aerosols eventually settle out of the atmosphere. How long does it take that to happen? 1 to 3 years. Now, the Ice Age was longer than that, so that means they must have been replenished with continuous volcanic activity. And he says that there's evidence of that. There's continuous volcanic activity during the Ice Age, so the aerosols would have been replenished regularly. However, this volcanism gradually decreased, but more importantly, due to evaporation, the oceans gradually did what? They cooled. And we'll also talk about how they changed in sea level and a little bit later on. But they cooled, because this is what evaporation does. I think the blank is oceans gradually cool due to evaporation. This is why you sweat, right? It's not that water itself cools you down. It's the evaporation of water off your body. It takes heat with it, so your body cools down. Now, Oard also talked about how, using the same meteorological understandings that we use today, we can infer general storm patterns for the ice that would have resulted in lots of precipitation in the very places that we see evidence of ice buildup. We talked about the evaporation in certain areas and the storm tracks. Okay. I think he's going to mention the length of the ice age in the next section, so we won't answer that question yet. If you have other questions, hang on to them. I want to make sure we have enough time to get through this last section and talk about it. So let's cue up the third section of the video. Now we're going to hear about what are some supports for this model of the ice age. How does it accord with some of the findings that we see around the world? You can use the back of your sheet. That's where more notes are.
And of course, Scandinavia. Now I'm going to go on to support for the model. There's lots of evidence for wet deserts, and I'm going to show you a diagram and a picture coming up. But the evidence shows that the dry areas about 30 degrees north, like the southwest United States, the Dead Sea area, Australia, lots of places were much wetter. Here's a plot of what's called pluvial lakes in the southwest United States, right in this area. Now, this is just in the Great Basin. There was lakes down in here. Death Valley had a lake about 600 feet deep. This is Lake Bonneville, which is a Great Salt Lake about 6 to 8 times as large, 800 feet deeper. By the way, the average depth of Great Salt Lake today is only 15 feet deep. It was 800 feet deeper during the Ice Age. Now, uniformitarians, how are they going to get a climate change to fill these things up in those areas? It is very difficult. But like I said, in our model, we fill them up first as the flood drains off. It'll fill up pockets or basins in the land at the end of the flood. And by the way, if you've ever been to these areas, there's beautiful, large shoreline features along this Lake Bonneville here, shorelines and high deltas. If you land at Salt Lake Airport, look out the window along the foothills and you see the shorelines. There's two distinct shorelines. In fact, I found shorelines around this lake. It's called Lake Lahontan. Today, you just have a few shriveled remnants of that lake. These lakes right here, they get up to almost 100 degrees now in the summer. I've taken pictures around there. There's a Mono Lake there, Glacial Lake, Mono Lake, and then Death Valley. There's shorelines around Death Valley. Quite a different climate during the Ice Age, a lot wetter. Now, it's interesting that the Sahara Desert was much wetter. Man lived in the Sahara Desert by the thousands, and he has all kinds of rock art. This is a picture of a giraffe on a rock in the Sahara Desert. And I'm going to just summarize a quote from the book, The Great Sahara. The Sahara is a veritable art gallery of prehistoric paintings. The evidence is enough to show that the Sahara was once a well-populated area of the prehistoric world. Yet, there is man's work in the most inaccessible corners of the desert. Literally thousands of figures of tropical and aquatic animals. Yes, aquatic animals. Enormous herds of cattle, hunters armed with bows and boomerangs, and even domestic scenes of women and children in the circular huts in which they lived. Why would the Sahara be much wetter during the Ice Age? Well, because you had a huge amount of evaporation right after the flood. The lowlands of Siberia, Alaska, and the Yukon were unglaciated, and this is a mystery. And here's a plot of the mountains being glaciated, and the lowlands, which are in yellow there, are unglaciated. By the way, most models of the Ice Age have extreme difficulty forming the Ice Age. Extreme difficulty. Now, some will produce it, but a lot of times it's because those models are tweaked to produce it. Anyway, Phillips and Held said in the Journal of Climate, Siberia and Alaska, well, they said, we now have glaciation. They did produce glaciation, but unfortunately, it was outside the areas where it existed during the last Ice Age. And that included the lowlands of Alaska, Siberia, and the Yukon. In other words, those lowlands like to glaciate. Why weren't they glaciated in our model? It's because of all the warm onshore flow. Mainly, it was the onshore flow that kept it ice-free. Now, the woolly mammoths in Siberia. What were millions of mammoths doing in Siberia where they couldn't live today? Mainly because it's boggy, they can't get around, and the bog vegetation is toxic to them because they ate grass. Not only was the woolly mammoths in Siberia, you had woolly rhinoceros, horse, bisons, a lot of different animals that lived in Siberia during the Ice Age. So what's going on? Why these sorts of things? Well, first of all, you got to determine whether the mammoths died during the flood or during the Ice Age. I think from what I've seen, from studied, it's overwhelmingly they died at the end of the Ice Age. One of the main evidence is in northwest Siberia, you find woolly skeletons on top of glacial till, which means that as the glaciers receded from northwest Siberia, the mammoths came up in that area, and then they died on top. So they died at the end of the Ice Age. That's the distribution right there, all across the northern hemisphere. In fact, you don't find them in areas where the ice lasted the longest, which is much of Canada and northern and central Scandinavia, which is what you'd expect during an ice age. And during the Ice Age, they would be able to migrate over a Bering Land bridge. The snow piles on land, it evaporates from the ocean, the original water, and the sea level drops. And the Bering Land bridge is very shallow, so man and animals could easily migrate into the United States and down through an ice-free corridor. They came down here and spread through into the southern United States, Central and South America. Now, a good indication that the climate was quite different during the Ice Age is the distribution of the saga antelope. The solid line there represents the current distribution of the saga antelope, and the dashed line is the historical. Their range is shrinking. But those dots represent Ice Age distributions. You can see them up in northern Siberia. What's so significant about that? Well, the saga antelope has thin hooves, and it likes wide open spaces, plains, and can't negotiate permafrost and swamps very well, indicating that this area was totally different ecologically during the Ice Age than it is there today. During the summers, it's quite a swampland because of the melting of permafrost. Permafrost melts that much, and it has nowhere to go, and so it ponds, and then you get all these plants growing in there, and it becomes a bogland. And it's hardly any animals can live there today in those areas. This is indication that we very likely had no permafrost during the Ice Age. Now, the uniformitarians, I think, have not really faced this problem because they grudgingly might say, well, maybe it was a little warmer climate, but some say, hey, it was during the Ice Age. It had to be a lot colder in Siberia. And they say, oh, that would solve the problem of those bogs. It'd freeze the bogs. Well, if it freezes the bogs, what are they going to eat? And here's a woolly mammoth timeline, whether you start with two
You can keep going.
elephants that leave the ark at the end of the Ice Age, or two woolly mammoths. I believe it was two elephants, and the mastodons and mammoths are part of the elephant kind. But regardless, they're going to grow slowly. They grow slowly, and then finally when their population is going to mushroom by geometric progression. Yes, you have plenty of time for millions of mammoths in a 700-year Ice Age. Finally, towards the end of the Ice Age, the climate changes. It's a dynamic climate. It becomes colder, drier, and windy, and they go extinct at the end of the Ice Age. This is the famous Beresavaka mammoth that was towed out of northeast Siberia, and that's generally the position they found him. It's in the St. Petersburg Museum in St. Petersburg, and it had a broken foreleg, it had broken ribs, broken pelvis, and it was in a general standing position. The question is that really plagues most people is, how did these animals die? Well, I believe the solution is found in the deposits surrounding the mammoths. Let's take a look at what they're buried in. Are they buried in bog material, river material? Some are in those, I think, but the mass majority of them are in windblown silt. This is a recent quote from a book called Mammoths and the Mammoth Fauna. A particular interest for paleozoologists is what's called the odama. The odamas are hills that are formed after permafrost melts around it and then leaves some permafrost as hills. This is actually a loess layer, that is windblown silt, as a rule containing the largest amounts of remains of late Pleistocene animals. They're buried in windblown silt. So what's the picture here? Well, I believe they died in large dust storms, sort of like what happened in the Dust Bowl era. This is a picture from the Dust Bowl era that if you were in a dust storm, you would see just a cloud of this dust coming, and the visibility would go down to zero. There might not be any wind right before it. It'd be like with a cold front. Sometimes there's no wind ahead of a cold front. Suddenly, the winds just really pick up, and the visibility drops to zero. And dust drifts, talk about dust drifts. During the Dust Bowl eras, dust drifts covered up fences, machinery. This one is up to the tops of a house. And by the way, I believe that the amount of windblown silt in those areas of Siberia, some places is over 100 feet thick. So I believe you had worse dust storms up there in Siberia than you did in the Dust Bowl era. They might ask, well, why are we going to have late Ice Age dust storms? Well, because of colder winters, colder oceans, which means more sea ice, which also means a drier atmosphere, and stronger north-south temperature differences, all resulting in lot stronger winds and dry, cold fronts, lot drier, cold fronts. So here's the big picture. Woolly mammoth, peacefully eating grass and buttercups. Yes, buttercups. The reason we have those is because they were in his mouth and in its stomach, half decayed. The digestion of a woolly mammoth doesn't occur in the stomach, it occurs after the stomach, by the way. I think that's a key to why the vegetation's only half decayed. But anyway, the winds come up. Uh-oh, he's going to ride it out. Guess what? He ends up like a snow fence. And what happens to snow fences? The snow piles up around it. The dust would pile up. He's starting to suffocate. And he's in a standing position. He tries to get out, and he breaks his right arm leg bone because it appears that he was alive when that front leg broke. And by the way, there's an analog for this in Hot Springs, South Dakota, where some of the mammoths that fell into that sinkhole, they've excavated 52 mammoths in Hot Springs, South Dakota in a sinkhole. Some of them have broken forelimbs also, that the researcher there thinks it was because they're trying to get out of the mud. In this case, the dust packing up would be almost like concrete. Finally, other dust storms totally cover him up. And he ends up in a standing position in the dust. And how do you get him in the permafrost? This has always been a major question. One person said, do you jam him into the permafrost? No, the permafrost in this case will come up to meet him. And by the way, permafrost also shifts and faults once you get it up there. And the faulting can break the pelvis of the Beryl mammoth and its ribs. So in a nutshell, that's the story of how I believe they went extinct. Also, something called disharmonious associations. They find, as a rule, you have animals that love the heat and love the cold that were buried in Ice Age deposits together. In the book Quaternary Extinctions of Prehistoric Revolution, it said the late Pleistocene communities, that's Ice Age communities, were characterized by the coexistence of species that today are allopatric, translated, not climatically associated, and presumably ecologically incompatible. Disharmonious associations have been documented for late Pleistocene Ice Age floras, that's your plants, terrestrial invertebrates, lower invertebrates, birds and mammals. In fact, it was common. And that's exactly what you expect, because this distribution would occur with cool summers and mild winters. While in the uniformitarian model, you have cold winters, period. You shouldn't expect that. One of the most outrageous instances is in England, where you have 100 associations of hippos with musk ox and reindeers in the same stratigraphic layer. How do hippos get up there during the Ice Age? Well, because I believe Britain was warm with a lot of warm onshore flow for quite a while and very wet, very heavy precipitation. So the hippo, after the flood and leaving the ark, would find it congenial up in there. And finally, as the temperatures cooled off, he found himself in the wrong environment, and he was being populated by reindeer and muskox and woolly mammoths. And finally, they all died and were buried in what it says here in this quote. In stratigraphic context, it seemed to indicate contemporary. In other words, they died at the same time. Also, they found out that when things were supposed to get better at the end of the Ice Age, it was warming up, the ice was melting. Suddenly, all these large animals disappeared on whole continents or went extinct all over the world. End Ice Age extinctions. 100 species of large animals in North America, that's 70%, died at the end of the Ice Age, including the horse and the camel. Europe and Asia lost 75% at the end of the Ice Age. Australia lost 90% at the end of the Ice Age. Why? Well, I think it's the same reason they were lost in Siberia. It was colder, drier, and windier. I think the dust storms, which there's lots of evidence, was a prime factor in the extinctions at the end of the Ice Age. Here's a quote from a recent book. After many decades of debate, the North American end Pleistocene megafaunal mass extinction remains a lightning rod of controversy. The extraordinary divergent opinions expressed in this volume show that no resolution is in sight. I would say it can readily be explained in the post-flood ice age model.
Okay, that's where it ends. We're pretty short on time, so I'll just go over these blanks briefly and then summarize the uniformitarian view of the Ice Age. But lots of information here, lots of further support for this model of the Ice Age, because an ice age caused by the flood is going to create unique climates, some of them actually really conducive for animals. And so you have animals and man. So you have wet deserts, that's that top blank there. We see evidence of this in southwestern United States and also in the Sahara Desert. You also have the unfrozen northern lowlands, which is strange because these areas like to become ice covered naturally. Why didn't they? It was because of the warm breezes coming off of the warm ocean, the onshore flow. This is something that a flood model of the Ice Age can explain, but normal uniformitarian explanations cannot explain why the lowlands did not freeze in Siberia, Alaska, and the Yukon. Fossil distribution of various animals also goes along well with this explanation of the Ice Age. Areas that the large woolly mammoths and other woolly animals lived in and died in, they're not hospitable today. So they must have been fertile during the Ice Age climate. And these remains cannot be from the flood because they're in glacial sediments, they're in glacial till, they're above flood sediments. And these animals are able to come to North America because of the lower sea level. More water was piling up on land in the form of ice because of the evaporation of the water in the ocean. So you had land bridges all over the earth, including the Bering Land Bridge. Saiga antelope distribution is similar. Woolly mammoths died because, and other woolly creatures, many other animals died due to the climate changes at the end of the Ice Age. Those mechanisms that had produced the Ice Age had eventually dissipated. Fertile northern plains became colder, drier, windier. So some places warmed up, other places got colder, especially those places that were warm during the Ice Age, like those northern plains. These conditions also created dust storms. And these storms sometimes resulted in the rapid burial and suffocation of animals like the mammoth. Lots of animals were dying towards the end of the Ice Age. And you have disharmonious association. Animals that don't live in the same climate were dying in the same area, which doesn't make sense unless you say the climate was changing. Animals that liked a warm area were already there. Then the climate began to change, and cold weather animals started to move in. And both of them ended up dying together. The cold animals due to various reasons, but the warm animals because they couldn't survive in that environment anymore. And you have lots of end of Ice Age mass extinctions. Dust storms were a part of it. The changing climate was a part of it. Surely man's hunting was a part of it. Lots of reasons why animals may have gone extinct towards the end of the Ice Age. So this is, again, a theory, but one that makes sense with a number of pieces of evidence. And it's all based off of the Genesis flood. But what about the uniformitarians? What do they think about the Ice Age? I'd like to give a more detailed explanation, but just due to time. They don't believe in a global flood, so they're not going to go with that. And they actually believe that there are multiple ice ages. The earliest ice age was 2 billion years ago. The most recent ice age was 2 million years ago. And these ice ages, they keep on happening because they're dependent on various cycles. They're dependent on the slight changes in the position of the Earth's orbit, there are slight changes in the position of the Earth's tectonic plates, slight changes in the Earth's atmosphere that produce these ice ages. They actually believe that we're in an ice age right now, and it's just that we're in one of those cycles where the ice is retreating, but 10,000 years or so from now, the ice will start going back again. Problem with these explanations is that they cannot produce the two necessary preconditions for the Ice Age: lots of evaporation and cooler temperatures. And when pressed, these scientists will admit that they can't really explain why the Ice Age started. They'll say that it's not well understood. But we have a good explanation. Again, we're not going to hold to this inerrantly like the Bible, but it makes sense. The flood, the global flood that God did send and that God did tell us about in the Bible, it produced the Ice Age that we see evidence for all over the earth. Just make sure I didn't miss anything. Okay, if you have more questions or comments about that, come see me afterwards. Next week, remember, we begin biblical archaeology. Remember, that's combined Sunday school, so make sure that your kids join you unless they're toddler or kindergarten age. We can't end today's class. I know I feel really bad about going over, but can't end today's class without reciting the memory verse. So hopefully you took some time to do that. That's Acts 17, 26 to 27. Let's see if we can recite it together, New King James Version. And he has made from one blood every nation of mankind to dwell on all the face of the earth. Oh, what's the next part? And has determined their pre-appointed times and the boundaries of their dwellings, so that they should seek the Lord in the hope that they might grope for him and find him, though he's not far from each one of us. All right, let's close in prayer. Lord God, you are great. You control all the storms. You control the climate. You control the tectonic plates. And God,